Hello everyone, I am Ashok from Academic Tutorial. So in this channel we are learning various topics related to strength of material. So today we are going to learn one of the most interesting and complex topic, that is complex stresses. So students are facing a lot of problem for derivation and solving the problem, and moreover the result of the problem is not coming correct. But we should clear our doubts and we will concentrate on this topic. Now let us start today's topic. So what is actually complex stress? So till date what we have studied is simple stresses. So there we have seen the stresses are acting in one plane which is perpendicular to the direction of loading. The stresses we have seen the direct stresses, that is direct tensile stress or compressive stresses, as well as the shear stresses. So the stresses was acting on a plane, and moreover we have considered one stress at a time. But in many cases, in many engineering problems, more than one stresses, that may be direct tensile, direct compressive, as well as the simple shear stresses act simultaneously over a body. Then the problem becomes complex stress strain problem. So in this session, we will consider two or more stresses acting simultaneously over the body, and what are the effects means the intensity of stress as well as the direction of stress produced in the body. So we will consider the first case, that is stress on a oblique plane under uniaxial loading. Under uniaxial loading. So this is the first case. So diagrammatically if we see, so this is the stressed body. The body is under only sigma x stress. So if we multiply sigma x with the area, then we will get the load in that particular direction. So we know that this is the x direction and this is the y direction and this is the origin. So only along x direction load is acting. So sigma x stress is acting along x direction, and this is called the stressed body. Stressed body. So we have taken one element from the body and given the name A, B, C. The element is separated and written here and drawn here, that is A, B, C. And in this chapter, we are going to find the stresses on planes other than the plane where the load is perpendicular. So that means on an oblique plane we are going to find the stresses. Now let the stressed element is drawn here. Stressed element. Now on this stressed element we have considered an inclined plane, that is AC. So before going to that, we will discuss one more thing. The width of the body is considered as unity, that is 1. So that what is the area of this portion, this length into 1, that is area of this length, that is AC into 1. Similarly, area of this side, that is BC into 1, that is area will be equal to the length of the line. So if we consider the width of the body as unity. Now This is the stressed element. In this stressed element, in terms of forces, if we express the stress in terms of forces, then along x direction, what is the load acting? Sigma x into this area is equal to BC into 1. That is sigma x into BC. Similarly, on this inclined plane, which is at an angle theta with x axis in counterclockwise sense, means this is the x direction, the inclined plane is considered at an angle theta with this direction in anticlockwise sense. Now, there are two stresses acting here, we don't know. So, we will find out the stresses. So, two stresses are acting here, that is sigma n perpendicular to inclined plane and the tau which is acting along the inclined plane. Now, in terms of forces, if we express sigma n into AC is the force acting perpendicular to inclined plane, and in terms of force, what is the tangential force acting on plane AC is given by tau into AC. Now we will draw the vector diagram. So consider an initial point. From this point along x direction, the force acting is sigma x into AC. With this direction, say this is the y direction, and with this direction making an angle theta, tau is acting, so this force tau into AC force is acting, making angle theta with x direction, and sigma n is acting, sigma n into AC is perpendicular to this direction, so this force is sigma n into AC. Now we are going to find out what is the value of tau and sigma n. What is the value of normal stress as well as shear stress acting on the inclined plane? That is our main target. Now, to find that, geometrically we will find out the angle. Okay, this angle we are going to find out. So, this angle theta, this angle is 90 minus theta. Okay, no problem. So, no need here. Anyhow, so this force which contains sigma x into AC. So, we will resolve this force into two components. So, theta is here. So, we can write the component of sigma x into AC, sigma x into AC cos theta. And the force perpendicular to this direction, that is this direction, that is sigma x into AC into sin theta. Now we have resolved this force, so we can remove this force. So now, for equilibrium of the element, this is the original point, equilibrium of the element. So along this tau direction, the sum of the forces will be 0. Similarly, along sigma n direction also, sigma n direction, the sum of the forces will be 0. Now, first we are considering sigma n direction. Okay, sigma n into AC, which is acting upward, and that will be equated to sigma x into AC into sin theta. Now, what is sigma n then? Sigma n is given by divided by AC, so it will give sigma x into AC. Sigma x into BC. Okay, so sigma n into AC, that will be sigma x into BC sin theta. So sigma n is equal to sigma x into AC by BC into sin theta. Sigma n into AC, tau into AC. and this one is sigma x into BC. So sigma x BC cos theta, sigma x BC sin theta. Now sigma n into AC is equal to sigma x into BC sin theta. So sigma n will be sigma x into BC by AC sin theta. Now this ratio BC by AC we can determine here BC by AC perpendicular to hypotenuse. So it will give you sin theta. So that means we can write sin theta into sin theta or sigma x into sin square theta. So that also can be written in standard form, that is sigma x by 2 into 2 sin square theta, and 2 sin square theta is equal to 1 minus cos 2 theta. So we can write sigma x by 2 1 minus cos 2 theta. So this is the value of sigma n we have got on an inclined plane which is at an angle theta with x-axis in counterclockwise sense. That is sigma n is equal to sigma x divided by 2 into 1 minus cos 2 theta. Now we will go for the derivation of tau. So from vector diagram we can see that both the forces are acting in one direction. That means sum of the forces will be 0, so that the element will be in equilibrium condition. So that means tau into AC plus sigma x into BC into cos theta is equal to 0. Or we can write tau into AC is equal to minus sigma x BC cos theta. Therefore, tau is equal to minus sigma x BC by AC into cos theta. So that is equal to minus sigma x. What is BC by AC? So BC by AC is sin theta. So we can write sin theta into cos theta. Sin theta into cos theta. Or we can write minus sigma x by 2 into 2 sin theta cos theta, or it is sin 2 theta. So we have got the result of sigma n and tau. So I am writing here what is the sigma n value. We have got sigma n, we have got sigma x by 2 into 1 minus cos 2 theta, and we have got tau is equal to minus sigma x by 2 sin 2 theta. Okay, I am removing this. Now we have seen the stressed body, in which stress was acting only along x direction, and we have taken one inclined plane, that is AC. AC was the inclined plane. The inclined plane was making theta angle with x direction, and the stresses developed on that inclined plane is given by sigma n, and this is given by tau. The sigma n value is equal to sigma x by 2 into 1 minus cos 2 theta, and tau is given by minus sigma x by 2 sin 2 theta. Now if we consider another plane, means if we vary the angle theta, so consider that this is the theta value. So now as the theta value changes, so this will affect the intensity of stresses. So that means intensity of stresses will vary at every inclined plane. So if we consider number of inclined planes which is making an angle with x-axis. So the intensity of stress will carry on varying. That is clear. And there will be some plane where the maximum stress will develop, that is shear stress. What is maximum shear stress in this case? So maximum shear stress will occur when sin 2 theta value will be maximum. Sin 2 theta value is maximum, then tau on the plane will be maximum. So what is sin 2 theta maximum value is 1. So that means we can write tau max value will be minus sigma x by 2, which is numerically the half of the stress applied in x direction. Okay, so these two cases, these two formula we have developed here for a body under uniaxial loading. Now we will see the other case, that is the second case, when the body is under bidirectional loading. The stresses on an oblique plane under bidirectional loading. Bidirectional loading. So consider the same body, this is the stressed body. Now along x-axis, along x direction, the stress acting is sigma x, and along y direction, the stress acting is sigma y. Width of the body we have considered unity. Consider an oblique section, that is AC, which is making an angle theta with x direction in counterclockwise sense. Now we are going to determine what is the sigma n and tau value developed on that inclined plane, that is on plane AC. Select tau is the stress developed, tangential stress, and sigma n is the normal stress on inclined plane AC. So first we will draw that element. Now this is the element. This is the A, B, C, and this angle is theta, because inclined plane makes an angle theta with that is x direction. What is the force acting along x direction? That is sigma x into area BC. Area is equal to BC. So sigma x into BC. Similarly, what is the force acting along y direction? That is sigma y into AB. We don't know what is the stress developed on inclined plane. Let sigma n and tau. So in terms of forces, we can write here the normal force, that is sigma m into AC, and the tangential force which is acting on plane AC is equal to tau into AC. Now we will go for vector diagram. Consider an initial point. So in x direction, what are the forces acting? That is sigma x into BC. So we are writing here sigma x into BC, force is acting towards right. And towards downward direction, what is the force is acting is sigma y into AB. Now with x direction making an angle theta, the shear tangential force is acting, that is tau into AC. And with this direction at an angle 90 degree, the force acting is sigma n into AC. So this is the total case and this is the initial point. So from initial point O, all the forces are acting simultaneously. Now our main idea is to determine what is sigma n and tau value here. So to determine the sigma n and tau value, So we will not disturb these two. So other forces. So that is this force as well as this force. We will just resolve these two forces. Okay. So this angle is theta. So we can easily write this angle is theta. Now just extend this. So once this angle is theta, this angle will be 90 minus theta and this angle will be okay. Or in other way you can find theta, this one is 90 minus theta and this angle is 90, so this will be theta. So once this angle is theta, so this angle is to be theta. So that you have to determine geometrically. So once this angle is theta, so if we resolve this sigma x into bc into two components, one component here sigma x into bc into sin theta cos theta, and along this direction will be sigma x into bc into sin theta. So we have resolved this one. So we are removing this. This one we have resolved. So we are removing this. Next we will resolve this sigma y into AB. So this angle is theta. So in this direction will be sigma y AB cos theta and perpendicular to this direction. Okay, along this direction will be sigma y AB and theta. And this is resolved. Sigma y into AB is resolved. So we are removing this. Now for equilibrium of this element, so along this direction the forces will be equal and along this direction the forces will be equal. Now balancing the forces along sigma n direction, we will get sigma n into AC, that will be equal to sigma x bc sin theta plus sigma y ab cos theta. Okay, now sigma m becomes sigma x into bc by ac sin theta plus sigma y ab by ac cos theta. Now what is the ratio BC by AC? We can find from here BC by AC. BC by AC, that is sin theta. So we can write sigma x into sin square theta plus sigma y into AB by AC, that is base by hypotenuse is equal to cos theta. So we can write cos square theta. Cos theta into cos square theta. Or we can write sigma x by 2 into 2 sin square theta plus sigma y by 2 into 2 cos square theta. So by using the formula we can write sigma x by 2 sin square theta is equal to 1 minus cos 2 theta plus sigma y by 2 cos square theta is equal to 1 plus cos 2 theta. Now multiply this and this, so that we will get sigma x by 2 plus sigma y by 2. So we can get sigma x plus sigma y by 2 plus sigma y by 2 cos 2 theta minus sigma x by 2 cos 2 theta. So we can write sigma y minus sigma x by 2 cos 2 theta. So this is the standard form of sigma n value. So we have got sigma n. What is the value of sigma n? Sigma x plus sigma y by 2 plus sigma y minus sigma x by 2 cos 2 theta. Similarly, we will determine what is tau value. So to get tau, so we will balance in this direction. In this direction. Tau into AC plus so we can write tau into AC plus sigma x into BC cos theta is equal to sigma y AB sin theta is equal to sigma y AB sin theta. Okay, so tau into AC becomes sigma y AB sin theta minus sigma x BC cos theta. Now tau is equal to divided by AC. So sigma y into AB by AC sin theta plus minus sigma x BC by AC cos theta. Or is equal to, you can write sigma y AB by AC, AB by AC, that is cos theta into sin theta, or we can write sigma y sin theta cos theta minus sigma x BC by AC, that is sin theta, so sin theta cos theta, So we have got this, so we can write sigma y by 2 sin 2 theta minus sigma x by 2 sin 2 theta. So we can take common sin 2 theta. Okay, we can take common sin 2 theta. So it will give sigma y minus sigma x by 2 sin 2 theta. So we have got sigma n and tau value. Now we will write sigma n and tau value separately. That is sigma n we have got how much? Sigma x plus sigma y by 2 plus sigma y minus sigma x by 2 cos 2 theta, and tau we have got is equal to sigma y minus sigma x by 2 sin 2 theta. Okay, so this is the sigma n and tau value. Now we will discuss from the stressed body, that is so the body was, the stressed body by this, body was under bidirectional load, that is along x direction. The stress acting was sigma y along y direction, and along x direction the stress was acting as sigma x. So we have considered an inclined plane which is at an angle theta with x direction in anticlockwise sense. So on that inclined plane, what is the sigma n and tau developed? That is the normal stress on plane AC is sigma n, and the tangential stress developed on plane AC is tau. So if sigma n and tau is developed on that inclined plane, so sigma n and tau value is given by sigma x plus sigma y by 2 plus sigma y minus sigma x by 2 cos 2 theta, and tau value is given by sigma y minus sigma x by 2 sin 2 theta. So we have got the solution. Now we will see the maximum shear stress. So to get the maximum shear stress, so this was the angle made by the inclined plane in this direction. The theta may vary from 0 to 90 degree. It can take any angle. So, if we put the value sigma n value or tau value 0 to that maximum, so the value of or intensity of tau will change as well as sigma n also will change. Now, what is the maximum tau? So tau max will occur when sin 2 theta will be maximum. What is sin 2 theta maximum value? It is 1. So the maximum tau max is given by sigma y minus sigma x by 2. So similar way we can find sigma n maximum value, that is cos 2 theta also will be maximum, that is we can get it. Okay, leave it. Tau max we have got it, so we will come in appropriate section. Okay, so this is all about the derivation of these two cases. The first case we have considered that unidirectional loading system, in which we have got the sigma n and tau value on an inclined plane, and also we have got the maximum shear stress occur in which plane, that is on at which angle. Okay, similarly we have seen the bidirectional case, that is in this bidirectional case what is the sigma n and tau value, so it is given by these equations. I hope this will clear your doubts regarding the complex stresses, and the rest of the cases we will discuss in the next video. And if you face any problem, so you can contact with me in the appropriate section. You just comment on the appropriate section, so I will come to you. Okay, so we will meet in the next video soon. Thank you. That's all for today's session. We would continue further on this topic in the next session. Keep being connected with us and ask any question in the comment section. Like, share, subscribe, and don't forget to press the bell icon to get notified for future videos. Thank you and see you soon.